A very good evening to all my lovely students. How are you doing? Welcome back to your own YouTube channel. Welcome back to the class of chemistry. Very good evening, Charan, Raghav Reddy. Yes. Good evening. Ganesh, good evening. Yes, very good evening, Telugu thumbnail designer. Alia Sheikh, good evening. Saisha, Ranga, Misbah ul Islam, very good evening, everybody. Pranati, good evening. Bharati, good evening. Sandeep, good evening. I am very good, Aradhya. How are you? All right. Yashasvi, Yoga. All right. Good evening, everybody. So I hope you guys are studying well and enjoying the classes which are happening here. Already 9 days have passed and we have enjoyed, I have enjoyed teaching you and you have enjoyed, studying. So that's a very good thing. Okay. Thank you, Ms. Ba. So 9 days have already passed and we have studied many important topics like first day we discussed about matter, second day we talked about what is molecular mass, what is molar mass, third day we went for mole concept, few days we have done mole concept unitary method questions, and then we went for the stoichiometry and how to do different 3 types of stoichiometry questions we have done. Basic stoichiometry, okay, basic stoichiometry we have done. Then we have done the limiting reagent stoichiometry. Good evening, Akshara. Good evening, Lasya. Then we have done percentage based stoichiometry where percentage purity is asked or percentage yield of reaction is asked or so. These topics we have done. Then I told you how to find percentage composition. Okay, percentage composition, that in a particular compound how much percent of element X, Y, Z is there. These 6-7 topics we have discussed. So almost your chapter mole concept, first chapter of your class 11th is almost complete. First chapter of your class 11th is 90% complete. Today we'll be doing the next topic of class 11th, which is the last topic of this chapter, which is going to be concentration terms. Very good evening, everybody. Okay, so we'll start with our today's topic. Today I am going to teach you about concentration terms. All of you would have heard about them or studied about them before somewhere in your class 10th, I guess. Good evening, Harita. So what is concentration term? See, whenever you go to a chemistry lab and you find any solution there, like this is the solution, always on the solution you will always find that some concentration will be mentioned here. Some concentration will be mentioned here. For example, if this is the solution, on the solution you will find that some sticker will be there. On sticker the concentration will be mentioned. Some concentration will be mentioned. Something like they might mention it as this is a 0.5 molar solution, 0.5 m HCl solution, something like this. Okay, there are so many ways the concentration can be defined, like molarity, weight by weight percentage, weight by volume percentage. They might mention it like this is a 20% weight by weight HCl, like that also they can mention. 20% weight by weight HCl. Like that, different concentrations are there which can be defined for a particular solution. So how to use mole concept in a solution we'll study today. How to use mole concept in a solution. So how to prepare a solution? You take some known weight of your solute. Solute is the one which you are dissolving. Okay. Transfer it to something called as a volumetric flask. This is a round bottom flask which is called as a volumetric flask. Here the markings are mentioned that up to here is 1 liter, up to here is 750 ml, like this. So you will take your known quantity of salt and you will add water into it. You will add water into it till the time the solution reaches up to here, and then you will dissolve it. You will shake it, and you will get a final solution. Now, depending on what is the concentration of the solution you want, you have to add water. How much water will be added and what will be the concentration of the solution, we are going to study today. So, when you take a solution, there are two things inside it: solute and solvent. Solute and solvent. When I ask most of you what is solute and what is solvent, most of you might give me a wrong answer. I'll tell you. So generally when I say solute, you will say the one present in lesser amount. Okay, generally what do you do is, you say the one present in lesser amount is a solute. Okay, but that is not the correct statement, everybody. Okay, that is not the correct statement. Solute is that particle which loses its physical state. Remember it. So if I take a solid and I take a liquid and I mix them together, if the final solution is liquid, that means solid has lost its identity. Solid has lost its physical state. So solid is the solute and liquid was the solvent. So please remember, the physical state of final solution will be same as that of solvent. If your solvent is liquid, solution must be liquid. Same way, when you take some solid, dissolve some liquid into it. When you take some solid, take some liquid, mix them together. If the final solution is solid, that means my solid is the solute and liquid is the solid is the solvent and liquid becomes the solute here. So who is solute? Remember it. Solute is the component of the solution. The component of the solution which loses its physical state in a true solution. Now the thing comes, sir, what if both of them are liquid? When you mix a liquid plus liquid together, yes, then Telugu thumbnail, your doubt is good. In that case, you will say the one liquid which is present in more amount. More amount does not mean more grams. More amount means more moles. The one which is present in more moles will be solvent, less moles will be solute. Or, you can mention, or the component of solution present in lower amount. Amount does not mean weight, beta. Don't check weight. Check moles. Okay? Don't check weight. Check moles. For example, if I take 90 grams of glucose and I dissolve it in, let's say, 90 grams of water, or I dissolve it in, let's say, 72 grams of water. If I make a solution here, finally glucose dissolved in water will become water only. A liquid solution only you will get. Here looking like water is in less amount. Water is not in less amount, beta. You have to see the moles, not the mass. So here glucose is actually how much? Weight is given, moles are weight by molar mass, which is 90 by 180. We have half mole glucose. And water is how much? 72 divided by 18. So water is actually 4 moles. So water becomes the solvent here. And glucose becomes the solute here. So this is the one. Okay. When you dissolve glucose plus water, all of you have done this at home. Whenever you dissolve glucose into water, finally liquidy solution is formed. No, it's not a solid. So when you take a spoon of glucose, put it into half a cup of water and dissolve it, then you will see that obviously the final solution will be liquid state. So whenever we say solute, we never say amount in terms of weight, we say amount in terms of moles. Keep this in mind. Okay, so the component of solution which is present in lower amount bracket by moles, lower amount bracket by moles. So what is solvent? Solvent always retains its physical state. Solvent always retains its physical state. So you can say solvent, the component which retains its physical state in the solution. Physical state in the solution, or the one present in larger amount, or the one present in greater amount by moles, present in greater amount by moles. Okay, so this is the one. Three types of solvents are there. See, there are actually 9 types of solutions you can make. 9 types. Solid in solid, solid in liquid, solid in gas. Okay, so we can take your solute as solid, then you can take 3 different solvents: solid, liquid, gas. When you take your solute to be liquid, you can take 3 different solvents: solid, liquid, gas. So solid in solid, solid in liquid, solid in gas. Liquid in solid, liquid in liquid, liquid in gas. Gas in solid, gas in liquid, gas in gas. 9 are possible, but for this chapter it is not our concern. In class 12th, a chapter will come by the name solutions, where we'll study about the types of solution. Right now my aim is to tell you how to find concentration of a solution only, okay, not the types of solution. There are 9 types of solution possible. Okay, solutions are of 9 types. You can write this word if you want. Solution can be of 9 types. Okay, total 9 types are there. Now let us start our today's concept. Today we'll be talking about concentration terms. Before we go on with the class, those who are chatting with each other here, okay, this is not a park. Okay, it's not a park that you're coming to. Panda, Pesal, Sheikh, Arifa, Satya, Pushpa. Although I generally ignore these things, I don't have a solid reason to say anything to you because I don't know who is watching the video. Might be a student, might not be a student, might be a commerce student or arts student, might be a 7th class student. But in case you are a fellow candidate who is planning to prepare for a doctor, many times I've told before also, we must behave like doctors in case we are planning to become one. Okay, I am a teacher, so I have a very moral responsibility to be very sophisticated, talk very softly, and we have to be soft spoken to all the students. I can't come and dance here. I can't come and just start shouting at you, because that's how teachers behave. They are soft spoken. They always respect the students. So if I am respecting you, you being you most probably are lower age than me. So it's a very moral responsibility that you should respect your parents, you should respect your teachers. Teachers should be respected even more, right? So kindly refrain from typing all these stupid things in the chat box. Anyways, I don't understand the Telugu. So yeah, but English to at least I understand. I can see that all nonsense things are only being talked here. Keep quiet. Okay, keep quiet. I will not be scolding you at all. I'll never scold you. All of you are doctors. I am just a teacher. All of you are going to be doctors. Doctors are much higher than a teacher. So I'll be respecting you. Okay. So you also try to respect your teachers as well. All right. So solution can be of 9 types. That is a later chapter part. That is a later chapter part. Okay. Sushant, you are not allowed to say this as well in the class. Okay. So let it be. I can ignore the chat box, that's not a problem. Just letting you know that we'll be doing wonders if we keep our mouths a little bit quiet for some time. So for the concentration terms, some abbreviations I'll be using like W, N, capital M, D. What are these things? Quickly write down in your notebook. Whenever we say 2 at the bottom, okay, 2 represents solute. And whenever you mention 1 at the bottom, 1 represents solvent. And whenever you mention nothing at the bottom, that represents generally solution. So when I say W2, W means given weight. So 2 represents weight of solute. So this is weight of solute in grams. W1 means weight of solvent in grams. Okay. 2 represents solute, 1 represents solvent. Same way M2 and M1. Same way M2 and M1. M, capital M means molar mass. Molar mass. M2 means molar mass of solute. Molar mass of solute. That will also be in grams only. And M1 means molar mass of solvent. Okay, so M1 mostly will be 18 gram because our solvent is going to be water. So M1 is kind of fixed. If you, instead of water, if you take benzene, then it will be 78 and all. M2 is the molar mass of solute. V means volume of solution. Nothing is mentioned at the bottom, no, V1, V2. So V means volume of solution. Volume of the whole solution. That will be in milliliter or maybe in liter depending on concentration term. D means density of solution. Density will be in the gram per ml. Density, other name is specific gravity. Specific gravity. Both mean the same thing. Both will be in gram per ml. Okay. Other name of density is specific gravity. When we say N, N means moles. N2 means moles of solute. And N1 means moles of solvent. You can keep writing them and remember them. So these are the short forms we'll be using from now on. So I'll not be saying the full definition every time. We'll just say N2 by N1, 1000 by, like that we'll be talking about. So big M means molarity. So these are concentration terms. Molarity is big M. Molar. So when I say 2M, means 2 molar solution, molarity of solution. Small m means molality. This is a different concentration terms. Okay, molarity, R is different, molality with the L is different. Both are very different. Molality of solution. N means normality of solution. If they mention NEQ, I mean, I'll be mentioning it like this, NEQ, although it is not required for these classes, this is little higher level when you will study normality. EQ means gram equivalents, just like there are moles of solute, same way there is gram equivalents of solute. So NEQ is number of gram equivalents of solute. It is not important for today. For today and next 3 days, it is not important. In case I teach you normality, then it will be required. But normality itself is a different topic. Okay, that will be dealt later. Gram equivalents. W by W means weight by weight percentage. Weight by weight percentage. W by V means weight by volume percentage. Whenever they mention X, X is also a concentration term. X is called as mole fraction. Okay, so X2 will be mole fraction of solute. Mole fraction of solute. X1 will be mole fraction of solvent. Mole fraction of solvent. solvent. Okay, these are things we are going to discuss in the next 2-3 classes. ppm is parts per million. Parts per million. So whenever your solution is very dilute, okay, in that case we use the terms ppm, ppb. Like for example, when you take your tap water is coming from the, coming from the well or coming from the underground. There is crores liters of water. In that, little bit amount of fluoride is available, potassium fluoride, little bit amount of sodium chloride is there. So that's why our water has little amount of ions. That's why we say the ppm of our water is 2.5 ppm fluoride, 5 ppm fluoride. If it is very high, then 80 ppm fluoride, 90 ppm fluoride, like that. So ppm is used for very dilute solution. ppb is used for even diluter solutions, parts per billion. Parts per billion. Okay, let us start with our first concentration term, which is going to be weight by weight percentage. Weight by weight percentage. As the name itself tells you, weight by weight percentage means how many grams of solute is present in 100 gram of solution. This represents mass of solute present. Whenever we say percentage always means out of 100. Percentage always means out of 100. So mass of solute present in 100 grams of solution. Mass of solute present in 100 grams of solution. So when I provide you a solution, let's say there is a solution, a bottle, where bottle has mentioned here that it is 5% glucose. Like this on the bottle it is mentioned. Okay, I provide you a bottle. In this bottle some solution is there. On the solution it is mentioned 5% W by W glucose. The meaning is, if I take 100 gram of this solution, there will be 5 gram of glucose inside it. Okay, if I take 100 gram of this solution, there is 5 gram glucose in 100 gram of this solution. That is the meaning of weight by weight percentage. Okay, so what is the formula of weight by weight percentage? How do you find any percent? When you are having an exam paper, the exam paper is of 80 marks. Exam paper is of 80 marks and you get 48 marks out of 80, let's say. You get 48 marks out of 80 marks. When I say what is your percentage, you will say, sir, marks obtained by total marks into 100. So your percentage will be 60%. Okay, so same way the formula is solute obtained by total solution into 100. Weight of solute by weight of solution into 100. That is the first formula that you are having. So percentage weight by weight formula is W2 by W into 100. W2 is the weight of solute in grams. W will be the weight of solution in grams into 100. Please remember, this is not the amount of water, it is the amount of total solution. It is not the amount of water, it is the amount of total solution. Okay, so when I take this particular solution that I have given you, there is 5 gram of glucose in 100 gram of this solution. Means when you take this 100 gram of the solution, inside it 95 gram will be water and 5 gram will be glucose. So 5 gram glucose dissolved in 95 grams of water. When 5 gram of glucose is dissolved in 95 grams of water, then total solution become 100 gram and it is 5%. So formula is W2 by W into 100, or you can also use the formula W2 by total weight means W1 plus W2 into 100. Okay, this is percentage weight by weight. So at the bottom, you will always be taking solutions weight and volumes. Never solvents. Never talk about water. Talk about total solution. Okay, are we ready for the first one? Are we ready for the first question? Yes or no? Is it clear to everyone? This is a simple one, no? Are you all ready for the first question? Yes or no? Quickly like the video and then I will show you the first question. Like the video. There are 65 likes. There are 350 students right now in the class. Once the like reaches to 200, I'll give you the question. Okay. Quickly like the class. Quickly like the class so that we have more of the serious students and less of the non-serious ones. Okay. Quickly like the class. Okay, good, very good. This is the very first question you have. Now you try to answer it, then I will be explaining the answer. Okay, I'll be explaining the question. First you try to answer it. Yes, I'm waiting for 200. Once the like reaches 200, quickly. Once the like reaches to 200, we will start with the question. Done, very good. Those who have done, very good, very good. Okay, so they are 160 now. Let us start. This is the first question. All of you try to solve this one. Yes, Sheikh, yes. "50 grams of urea is dissolved in 200 grams of water. 50 gram urea dissolved in 200 grams of water. Find weight by weight percent." Quickly. Quickly everybody, get the answer. Some of you are saying A, some of you are saying B. So those who are saying A, these people are getting stuck in the jal. These people are getting stuck in the jal. B is the correct answer, everybody. B is the perfect answer. 20%. Okay, so the jal is that directly you are dividing 50 by 200. Why you are dividing 50 by 200? When you take 50 gram of urea and dissolve it in 200 grams of water, total solution will become 250 gram. So weight of solute, always when you are starting concentration term questions, step one, write the given data. Write given data. Step 2, put formula. Step 2, put formula. That's all. Nothing else you have to do. First you have to write the given data and then use the formula. So W2 is given 50 gram. It is dissolved in 200 gram water. Water is 200 gram. So when I add them, solution will become 250 grams. Then put the formula. Formula was weight by weight percent was W2 by W into 100, which is 50 gram by 250 gram into 100. This goes 5 times 100 by 5, 20%. 20%. Yes. So that's how you don't do the mistake next time. Water is different, solution is different. Water is different, solution is different. Are you all ready for the next one? Quickly go for the next one now. Write it down along with me. Okay, don't be slow. Keep writing it. In case you miss writing any question, watch the video once again and write it. Next one. Find this one. Okay, I'll give you 1 minute. Read the question carefully and answer. Calculate the moles of NaOH in 30 grams of an aqueous NaOH solution, which is 17% by weight. Find the moles of NaOH. Find the moles of NaOH in a 30 gram aqueous solution, which is 17% by weight. All of you do. Okay, many people are saying option C. Clap for yourself. Your answer is absolutely correct. Option C is absolutely perfect. Option C is absolutely perfect. So what are the things given? Step 1, I will write all the given things, everybody. Step 1, calculate the moles of NaOH. Moles of solute they are asking. 30 gram of aqueous solution is taken, means W is given. W is 30 grams. W is 30 grams. Percentage is given 17%. So percentage weight by weight is 17%. Okay. So this will help us to find weight of solute. First we'll find the weight of solute. So step 2, put the formula. Weight by weight percent equal to weight of solute by total weight of solution into 100. So weight by weight is 17. Weight of NaOH I'll find from here by total solution is 30 gram. Okay, it is given 30 gram of aqueous NaOH solution into 100. So from here W2 comes out to be 5.1 gram. Okay, 5.1 gram, all of you can easily check. 5.1 gram you are getting from here. Okay, 317 times is 51. So 510 by 100, 5.1 gram. Don't directly look at W1 and answer it like this here. W1 is the weight we got, weight. But the question is to find moles. We know that moles is equal to weight by molar mass. Moles formula was given weight by molar weight. So weight of NaOH is given 5.1 gram and molar mass of NaOH is 40 gram. NaOH. Sodium 23, oxygen 16, hydrogen 1. When you add them, it is 40. So the answer is 5.1 by 40, which is 0.17. 0.127, sorry. 0.127. 0.127 mole. This is the answer. Okay, I hope all of you got the correct answer. Now let's go for the next type of concentration term. Next type of concentration term is very similar to this one, that is weight by volume percentage. Weight by volume percentage. Previous one was what was the mass of solute present in 100 gram. Now mass of solute present in 100 ml of solution. Okay, it is mass of solute present in 100 milliliter of solution. 100 ml of solution. So when I give you a let's say 20%, if I give you a 20% weight by volume HCl solution. If I give you a 20% weight by volume HCl solution, the meaning is when you take 100 ml of this solution, there will be 20 grams of HCl inside it. Okay, there is 20 gram HCl in 100 ml of this solution. So when you take exactly 100 ml of this solution, in that 20 grams of HCl will be present. If you take 200 ml, 40 gram will be present. If you take 50 ml, 10 gram will be present. Simple unitary method you can apply. So formula becomes percentage weight by volume is weight of solute in grams by volume of solution in ml into 100. Into 100. Simple. This is our equation number 2 we got. So total 2 equations we have done today. W2 by W into 100, W2 by V into 100. Okay, let's do 2 questions from here and then we'll move to the next one. Do this question, everybody. Get the answer. Get the answer. How much glucose is present in 2.5 liter of a 2% glucose solution by volume. By volume. Calculate the weight of glucose present in 2.5 liter of a 2% glucose solution. 2% is by volume. By volume means at bottom volume is there. By weight means weight by weight. By volume means weight by volume. Okay, very good. 50 gram is correct. You could only do it by unitary method also. You could also do it by unitary method. Unitary method will say, sir, 2% glucose solution means if I take exactly 100 ml of solution, let's say this solution is 100 ml. In this 100 ml, exactly 2 gram glucose is present. So, sir, when glucose is 2 gram, then solution is 100 ml. So, you will say in 100 ml, 2 gram glucose is present. 100 ml solution contain 2 gram glucose. And now sir is asking 2.5 liter will contain how much glucose? 2.5 liter means 2500 ml solution will contain 2 by 100 unitary method into 2500, which is 50 gram. You could just do it by unitary method. All concentration terms question you can attempt by unitary method also. Just think what is the definition of the given concentration term. From the definition, I guarantee you can get all the answers. Just draw a figure like this. Even the most difficult question can be solved within 1 second like this. Otherwise, use the formula. Weight by volume percent equal to W2 by W into 100. Weight by volume is 2% given, W2 they are asking, volume is 2500 into 100. So W2 is 50 gram. Now I want you to do another question. The next question I want you to do by unitary method. Okay, little difficult, little extra. Then I'll give you a formula also to learn. Okay, let's convert now one percentage to another percentage. So interconversion of weight by weight and weight by volume. First you think about it. Interconversion of weight by weight percentage to weight by volume percentage or vice versa. Very important, very important from NEET point of view. Very important question from NEET point of view. Yes, Harita. Percentage always means per 100 gram. Percentage is always out of 100. Percentage is never out of any other number. A solution of NaOH is 22% by volume. Find weight by weight percentage if density of the solution is 1.2 gram per ml. I want you to think about it. Okay, use your brain. Use your brain, try to think. I'll give you time. Okay, don't just go by all the formulas and all. Think about it. A solution is 22% by volume. Think about it. So a solution is 22% by volume means 22 gram NaOH in 100 ml of solution. Okay, sir. One thing I'm clear with. What is weight by weight percentage if density is given? B, many are saying B option. Many are saying B option. Let me tell you B is incorrect. A. Krishna says A. Divya says A. Do you want to know the answer? Do you want to know the answer to this question? If yes, like the video, then we'll start. Those who have not liked the video till now, you can like the video, then I'll tell you the answer. Then I'll tell you the answer. B is correct, sir. Hasif, I don't think B is correct. Let me see. Let us see which will be correct. Yes, let us see. All of you see here. So there is a solution given to you. Solution of NaOH is 22% by volume. 22% by volume means if I take exactly 100 ml of solution, volume of solution I have taken exactly 100 ml. Inside this solution, weight of solute is 22 gram. Okay, this is the solution given to you. This is the given solution. A solution was given to you whose volume was exactly 100 ml and in that 22 grams of solute was dissolved. Now, what is the question they are asking? Find its weight by weight percentage. We know that percentage weight by weight is nothing but weight of solute by weight of solution into 100. See, volume of solution you know. Density you know. If you know density, if you know volume, can you find weight of solution? If I know that this solution is 100 ml, if I know that its density is 1.2 gram per ml, can I find its weight? Answer is yes. Yes sir, we can find. So using density, convert volume to weight. That's all. So we can say density equal to weight of solution by volume of solution. Weight of solution by volume of solution. Density is given 1.2, weight is W, volume is 100 ml. So from here I get weight of solution, same solution is exactly 120 gram solution. So this solution having a volume of 100 ml is having a volume of 100 ml, but on the weighing scale it weighs 120 gram. It weighs exactly 120 gram solution. Okay, that's how we can make the figure. So I made a figure where it says 22% by volume. So 22 grams dissolved in 100 ml solution. Using the density, I converted the volume of solution to the mass of solution, 120 gram. Then I'll use the formula. So there is 22 gram of solute dissolved in 120 gram of solution. 22 grams of solute dissolved in 120 grams of solution. So this is the answer. This is 11. So on the table of 2, it is going at 11 times 110 by 6, which is 1.8. So 18.33%. Is it clear, yes or no? Is it clear to everybody what we are doing here? Now you might say, sir, every time we have to think like this. Yes, every time you have to think like this. If you want, I'll give you the formula. You can learn the formula also. Formula is, learn the formula if the unitary method you cannot perform every time, but it's simple only. I just told you, draw a figure. Draw a figure. From the figure, whatever things are given, you write down. 22 gram in 100 ml. Converted volume to mass, then put the formula. Otherwise, the direct formula for interconversion, very important formula, you can write it down. The formula for interconversion is going to be weight by volume is equal to weight by weight percentage into density of solution. This is the formula that if you want, you can directly use the formula also. Weight by volume is equal to weight by weight into density. Weight by weight into density. Okay, weight by weight into density. You can easily see here that how did we reach to this formula? We know that weight by weight percentage is W2 by W into 100. If I multiply this with density, I'll get W2 by W into 100 into density. Density is nothing but weight by volume. WW will cancel out. So we have reached to weight by volume percentage. Okay, so when I take W by W percent, if I multiply by density, it automatically becomes weight by volume percent. Is it clear to all of you, yes or no? If this question is clear to all of you, quickly you can just say crystal clear, and then I will end this class. Thank you, bye bye. Just I'll wait for your last message and then we are going to close this class. Bye bye everyone, take care. See you all in the tomorrow's class with more and more concentration terms. Quickly you can confirm. Clear, okay. Yes, okay, bye bye. Thank you.